Lesson 5A, we're going to look at the empirical rule, and the empirical rule has to deal with something called the normal distribution, which is what this whole unit is going to be about. You've probably seen this before. It's also known as a bell curve, and it makes this nice little shape. It's a symmetrical distribution. The mean is in the middle. Okay, and so most of the data points are next to the mean, and then when we get further away, so like let's say this was like temperature, the average temperature is in the 70s, so there's a lot of days in the 70s, and then as we get colder or warmer, there's fewer days that have that temperature. All right, and so there's a special thing about the normal curve called the empirical rule. And what the empirical rule tells us is how much of the data fits into each section of the curve, and this is broken up by standard deviations. Okay, so the mean goes in the middle, and then going to the right, we're adding the standard deviation. So 1 standard deviation higher than the mean, 2 higher, 3 higher, or going the other direction, 1 less, 2 less, 3 less. All right, and these numbers are numbers that you need to know. 68% fall within 1 standard deviation, 95% within 2, and then 99.7 is within 3. Okay, so what that means is this from 1 standard deviation below to 1 standard deviation above, that area is 68% of the data. So whatever our data is, 68% of it is going to fall in these two sections. Okay, and because the curve is symmetrical, that means that the mean is going to cut this section exactly in half. So each piece is going to be 34%. 68 divided by 2 would be 34. Okay, then for the next piece, all right, we know that 95% of the data falls within 2 standard deviations. Whoops, sorry. Okay, so this whole area that I've highlighted in green, that is 95% of the data. Now, if I want to find these 2 little pieces, I got to do some math, okay? I know that the yellow area is 68%. So if I take my big green area and subtract my little yellow area, that will give me this section and this section together. And so that is 27. So this piece right here, this piece right here have to equal 27, all right? And just like with the 68%, we know that they have to be equal because the mean cuts everything in half. So if I take that 27% and divide it by 2, that leaves me with 13.5. So each of these sections are 13.5% of the data. All right, and then we're going to go out to 3 standard deviations. So that is 99.7% of the data is in that big blue box. All right, and we're going to do the same math that we did before. So 99.7, the blue box, minus 95, the green box, is 4.7. So I know that this area and this area together have to equal 4.7, and that they have to be equal to each other. So I divide that in half, and I get 2.35. All right, now we have these little leftover pieces, and those are important. We can't neglect those, so we have to find out what those are. Okay, so again, same math. Those little pieces, I need 100%, right? Everything should add up to 100%. Okay, so if I take the blue out, the 99.7, that leaves me with 0.3% left. And just like with everything else, those 2 pieces have to be equal, so I divide them in half. So these little pieces on the end are both 0.15%. All right, so here's what it looks like with everything cleaned up. This might be a good time to pull your phone out and take a picture, because you're going to need these numbers, and you're going to need to know these numbers and be able to fill them in. Okay, so we'll look at a practice problem using the empirical rule. So we have the scores on the stats final exam. There's a mean of 78 and a standard deviation of 3, and then a bunch of questions that we have to answer. So first thing I'm going to do is I'm going to take this normal distribution that we have filled in with the percentages, and I'm going to fill in these marks based on this information. So I know that the mean is 78. The mean always goes in the middle of my distribution. Okay, and then what I'm going to do to get these, I'm going to add, or going to the left, subtract the standard deviation. The standard deviation is 3. So 78 plus 3 would give me 81, plus 3, and then go in the other direction. 78 minus 3 would give me 75, minus 3, minus 3. Okay, so now I know that 34% of the test take scores were between 75 and 78. Okay, and so let's answer these questions. What percent of students scored higher than a 78? All right, so I want to know all of this. Anybody that's bigger than 78. And so what I'm going to do is I'm just going to add those percentages together. All right, 34 plus 13.5 plus 2.35 plus 0.15, and that is 50%. All right, 50% of students scored higher than a 78. Second question, what percent of students scored lower than a 75? All right, so now I want everything that's 75 and below. We're going to do the same thing. We're just going to add those numbers together. So 0.15 plus 2.35 plus 13.5, 16% of students scored lower than a 75. All right, and then what percent of students scored between 75 and 81? So again, I'm looking for this area right here in between a 75 and an 81. So I'm just going to add those two sections together. 34 plus 34 is 68%. Okay, then these last two questions are a little bit different. We have to do some thinking here. All right, so what range of scores contains the middle 95% of students? So what I know is 95 is one of my numbers from the empirical rule, and that's for 2 standard deviations. So I need to go 2 standard deviations below the mean and 2 standard deviations above the mean to get that range. Okay, so 2 below gives me 72. 2 above gives me 84. So the middle 95% of students scored somewhere between a 72 to an 84. All right, and then our last question, if there are 160 statistics students, how many scored higher than 84? All right, so this time, all these other questions ask us for a percent. This one, we're looking for an actual number out of 160 students. So the first thing is, we're going to do it just like we did questions 1 through 3 up here. I want to know what percent of them scored higher than an 84. Okay, so these two sections together equal 2.5. So 2.5% of students scored higher than an 84. All right, if I want to know the number of students, I'm going to take that percent as a decimal, 0.025. I'm going to multiply it by the number of students, 160, and I get 4. So 4 students out of the 160 scored higher than an 84. Okay, and that is it for 5A.